Let's summarize now the different methods of preparation of the alkyl halides. We can get alkyl halides from the alcohols. So first source is here from the alcohol, and you can react it with the halogen acid, and then what do you get? You get an alkyl halide. This is a nucleophilic substitution reaction, chlorine replacing the hydroxide. You can use the other reagents also, like you can use this SOCl2, thionyl chloride here, and again what do you get? You get the RCl. Okay, so here this hydrogen reacts with the oxygen and you get a water. Here you get HCl gas and you get the sulfur dioxide. Okay, we can use other reagents here, like you can use the PCl5. Again the PCl5 here, the chlorine replaces the hydroxide, so you get the RCl, plus you get the POCl3 and you get the HCl, hydrochloric acid. You can also react with the PCl3 molecule, trichloride rather than pentachlorides. Again, from the trichlorides, the chlorine replacing the OH, you get this one, right? But the difference here is that in the PCl5 and the PCl3, trichloride and the pentachlorides, trichloride, one molecule of trichloride, it reacts with the 3 molecules of alcohol. Okay, so you need 3 molecules of alcohol to react with the PCl3. So it can react with 3 alcohol molecules, while as a PCl5 it reacts with 1 of the alcohol molecules. So this is the one method of getting the alkyl halides, and all these reactions are basically the acid reactions, nucleophilic substitution reactions here. Okay, so another source of getting this alkyl halide is alkenes. From alkenes you can get alkyl halides by adding halogen acids, like so the HCl we can add across the double bond. This is propene here, 1 2 3, this is the propene, and you can add the hydrochloric acid. And what you get now? You get actually here this product, you get the 2-chloropropane. Why? Because this is the addition reaction here, hydrogen adds to this particular carbon and the chlorine to the central carbon here, right? So here we know the major product actually you get as per the Markovnikov's rule, right? Markovnikov's rule says that when you add to an asymmetrical alkene an asymmetrical reagent, hydrogen is added to that double bonded carbon that has more number of hydrogen atoms. So this particular terminal carbon here has 2 hydrogens and this central carbon here has 1 hydrogen. So the double bonded carbon with more number of hydrogens is this one. So the hydrogen will be here and the chlorine will be here. So that means this is the major product because it is formed as per the Markovnikov's rule. You also get another product also, that is formed in a very small quantity, and that will be the 1-chloropropane. That is the minor product, right? This is the minor product, and this is the anti-Markovnikov product also. You can call it as anti-Markovnikov product because here the hydrogen is added to the central carbon and the chlorine goes to the terminal carbon, right? So, but this one is a major product, right? This is always the major product, and this is a Markovnikov's product here. Addition follows here the Markovnikov rule, which says that hydrogen is added to that double bonded carbon with more number of hydrogen atoms, right? You can also add HBr and other things to it, but all those additions they follow the Markovnikov's rule. There's one exception, and the exception is that if you add HBr in presence of poor oxides, only the HBr, not the HCl, remember it, HBr in presence of poor oxides, okay, in presence of poor oxides, then what do you get? You get an anti-Markovnikov product will be the major product. So that means here the hydrogen is added to the one with less number of hydrogen atoms. Hydrogen is added to that double bonded carbon with less number of hydrogen atoms. So that means here you get a 1-chloropropane will be the major product here in case of the addition of HBr in the presence of the poor oxides. Alright, so the third source of getting the alkyl halides is alkanes, like the CH4 molecule. You can react with the alkanes with halogen molecules and heat it strongly or use high energy radiations. Alright, so what happens here now? Chlorine replacing the hydrogen from this one. So if you replace a 1 hydrogen atom by chlorine, so monochlorination will get a product CH3Cl. Right, so this is a substitution reaction, right? This is a free radical substitution reaction, and the mechanism here is the free radical mechanism. And we know that in the free radical mechanism you have it has one of the drawback that you don't get a one product. most often in the free radical substitutions you get more than one product. The reaction doesn't stop actually here, it can further undergo the the substitution. But if you say the monohalogenation, you only get this one, because you can further otherwise replace the hydrogen atom by the chlorine, and then what do you get? You get the CH2Cl2 here, okay, and then again you can replace this one more hydrogen atom and you get the CH3Cl. Again you can replace with you get the CHCl3 here, right? Sorry, so you can replace the fourth hydrogen also here, and then you can get CCl4. The CCl4 is the product that you get from the methane only when you take chlorine molecule, chlorine as an axis reagent. Alright, so these are the three main methods of getting alkyl halides: from alcohols, from alkenes, and from the alkanes. There are a couple of more reactions of getting those alkyl halides, and one of them is by the Halide exchange, right? And we call it as a Finkelstein reaction. The Finkelstein reaction is basically the preparation of an iodoalkane from the bromo or the chloroalkanes, right? So let's take an example: CH3, CH2, and the bromine here. You can replace this bromine by the iodine, and you get the iodoalkane, right? So if you react with the sodium iodide, well, then what do you get? You heat it then, and what do you get? You get the CH3, CH2, and I, right? And you get NaBr there, correct? You get the NaBr. Here this is a halide exchange. The bromine is being replaced by the iodine, okay? So this reaction is called as a Finkelstein reaction, right? This is a Finkelstein reaction. And another reaction is there, getting these the bromoalkanes, and you can get the bromoalkanes from the Hunsteiger reaction, right? The Hunsteiger reaction. Okay, the Hunsteiger reaction is reaction of the silver salt of the fatty acids. Okay, the silver salt of the fatty acids, like the CH3, CH2, COAG. This is the silver salt of the fatty acid. Okay, the carboxylic acid, and this is the silver salt, right? So you react with the bromine, then you heat it strongly, and what do you get? You get the CH3, CH2, CH2Br, and this is replaced here. This group here is actually removed from this one as a carbon dioxide group, and you also get the silver bromide, AgBr. So this reaction is called as a Hunsteiger reaction. Okay, this is the Hunsteiger reaction, and the top one is the Finkelstein reaction. Hope you got it. Thanks for watching the video. Bye for now.